Hello, everyone. So for me, this is the third or fourth time I've tried to do this video. The previous um, video system has just created me some real problems. So I'm trying a new system. We'll see how it works. Hopefully it works better than that. This is chapter 2, everything you want to know about research but we're afraid to ask. It's a good chapter. And your text does a very good job of outlining the basic principles of research. We'll follow it pretty closely. What we're going to start with is the first lecture of the two from chapter 2. We will cover the 5 basic steps of scientific investigation. We'll talk about the 4 types of research in psychology, and then we will discuss some of the basics around the methodology of psychology, or psychological research. Then in the next lecture, which I'll put out this evening, is going to talk about data collection, data analysis, and the basic ethics of especially human research. But we'll talk about animal research also. So let's start with the 5 basic. Before we do that, let me just mention a couple of things. I'm hoping you all know that I extended the time that you could finish chapter 1 and chapter 11 assignments and tests. I hope you've taken advantage of that. I did send out an email to everyone letting you know that that's what I was doing. So I hope you get that. All right, 5 steps of scientific investigation. I'm going to go through these pretty quickly, and then we'll talk about each one in much more detail. The first is hypothesis. You have to come up with an idea of what you're doing your research about. What is an hypothesis? Best definition is it is an educated guess about whatever topic you're studying. An hypothesis is a statement of belief. You believe a certain concept, and you're presenting it as an hypothesis, trying to use that then to set up a piece of research that can either substantiate it or contradict it. Why do we do research? Well, the reason we do research is because we want to be able to predict. That is the purpose of research. All those ethereal ideas of to gain knowledge and wisdom and all that kind of stuff, those are all great, and it's not that they're wrong, but they are not really what we're looking for. What we're really looking for is the capacity, the ability to predict. In this case, let's say Fred the psychologist came up with a new therapy for depression. It's the bestest, greatest, newest, brightest and whitest therapy for depression ever. Well, he's saying that, but how does he provide some evidence for that? Well, Fred would come up with an hypothesis. Fred's therapy for depression works. Well, it's not going to be that simple. First of all, we have to know what Fred's therapy is, and we have to be able to describe it in such a fashion that anybody who is trained in psychotherapy would be able to do it just fine. Secondly, we have to understand what depression means. Our subjects, are they going to be severely depressed, moderately depressed, mildly depressed? Well, we're probably not going to have severely depressed people in our study. We're only going to have moderately or mildly people in our study, depressed people in our study, because people who are severely depressed are most likely going to be suicidal. We're not going to use an experimental method on people who are severely depressed and are suicidal. On the other hand, people who are mildly depressed, we're probably not going to use them also, because that would wash out our study, meaning they don't have to change very much to get out of depression. And so only a little bit of change wouldn't really give a whole lot of good proof in our statistics. That being the case, we'd probably end up with moderately depressed people. And then works. Fred's therapy for depression works. Well, what does works mean? Well, we would have to determine at a statistical level what works would mean for us. How much change would have to occur before we would say that a sufficient amount of change actually occurred. So, that all being the case, that's what an hypothesis is. The second step of scientific investigation is design and methodology. Well, what does that mean? Well, design and methodology are all of the ticky-tacky details that you have to put together and do to make the research work, to be able to be a good piece of research. Now, there are 4 principles in design and methodology, specifically for the experiment, because what we're talking about right here is the experiment. 4 concepts that you need to know. If you don't understand these concepts and how these 4 concepts work together, you will not understand this chapter. All you'll be doing is memorizing information. So take the opportunity to understand these 4 principles. Independent variable, dependent variable, experimental group, control group. Independent variable, dependent variable, experimental group, control group. Those 4 concepts, if you understand them, the rest of the chapter will make sense. And that is included in the design and methodology section, section 2 of the steps of scientific investigation. There are other things in this area that we'll talk about. We'll talk about random selection and random assignment and a number of other principles, but the 4 basic ones are the ones that I just mentioned to you. The third step is data collection. People think data collection isn't that big a deal. Well, really, if you think about it, data collection is the true empirical process. It's the observation. You said that something will change something else, and now you're trying to measure it. Well, the measurement of it is the data collection. And you can have the greatest hypothesis and the greatest design and methodology, but if you mess up in data collection, you blow your whole study. It's really pretty bad. So you have to be very careful how you go about collecting the data so as not to create bias in the outcome. And we'll talk about that. Fourth, data analysis. This is statistics. We won't talk a whole lot about statistics, but you'll need to know some information. But overall, we'll talk about statistics and what they are and how they are used to show whether or not the change has occurred that we hypothesized would occur. And then finally, step 5 is conclusions and reporting of your findings. We make conclusions after we've analyzed the data. Either people changed as much as we thought they would, or they didn't, or whatever the case may be. But also, we have to report all of our findings. That's what an ethical researcher does. You don't only report the findings that you think are going to help your cause. You report all the findings. And this is an important principle. That's an ethical perspective. And then also, after we're done talking about these 5 steps, we're also going to talk about ethics in research, both for human and animal research. Now, let's start by talking about the 4 different types of research. Okay? Now, there are 4 basic types of research that we can use in psychology. Yeah. Hang on a second here. Okay. So, At one end of the continuum, you have naturalistic observation. That's what I've put as NO, naturalistic observation. Okay? On the other end is the experiment. So you have two extremes. Naturalistic observation on one end, the experiment on the other. The thing that defines the two ends of this continuum are very simple. It is control of variables. Naturalistic observation doesn't want to control any variables. The experiment wants to control all sorts of variables. And that's why they're on opposite ends. We'll talk about variables in a little bit and talk about what that means. And there are two other types of research. There's the case study or case history. We've already talked about that a little bit. Some of you may be doing that for your project. And the other is a survey. So you have the case study and the survey. Now the survey is closer to the experiment because the survey is going to control quite a few variables. We'll talk about that in a minute. On the other hand, over here, the case study doesn't want to control variables very much. Not very much at all. So therefore, it's going to be closer to naturalistic observation. Now let's talk about all four basic principles. Okay? So, naturalistic observation. This is where you observe subjects in their environment and they don't even know they're being observed. So this would be people in a room that has a two-way window mirror, and you can see into the room and they can't see out, and they don't know they're being observed. That would be naturalistic observation. In the wild, this is filming animals without them knowing that they're being filmed. A classroom might be an environment that could be infiltrated. What if a school psychologist goes in to observe what the students are doing, maybe one or two students that they're thinking about working with or testing? Well, they'll want to go in and observe. Well, the moment that psychologist comes in, is there a problem with the behavior of the students? Well, when we say problem, we may not be saying that they are being problem students, but what we are saying is these students are going to change their behavior when someone new enters the room. That's why naturalistic observation here only includes observation without the subjects knowing they're being observed. So there's no control over any variables. You're not limiting anything. All you're doing is observing to collect observational data. A case study is where you are observing one person. Now, interestingly, a case study is much like a psychological evaluation, where the subject knows they're being evaluated. They know everything about the evaluational process. But you're not limiting any of the evaluation process, not in the slightest. You want as much information, as much data as you can get about this one person. That's what a case study or even a psychological evaluation is all about. So we use numerous sources of data to bring information about that person. A survey, on the other hand, is going to control a lot of variables. First of all, the subjects that the survey is sent to. Are you going to control aspects of that variable, subjects? Well, yeah, you are. You may only choose people between the ages of 18 and 35, or you may only choose females, or you may only choose males, or you may only choose individuals who have completed college, or whatever the case may be, whatever variable you're using here in the survey, you're going to control aspects of that variable. And then in the experiment, our goal is to control the variables. That's our purpose. Now, there is a major division between the experiment and all other pieces of research. The experiment permits us to do something that none of the other pieces of research do: cause and effect. So the experiment is specific to cause and effect. Surveys, case studies, naturalistic observation, none of them can measure cause and effect. Why? Because they have no cause. The cause is the thing you're studying, the thing you're trying to prove, whether or not it works or doesn't. Well, a survey, you're not giving some subjects something and giving other subjects nothing to see if the people who got something perform differently than the people who got nothing. You're not doing anything like that. All you're doing is giving everybody the same survey. Therefore, a survey doesn't have cause and effect because you're not trying to cause any kind of change. With a case study, you're not trying to cause any kind of change. You're just trying to gather information. There's no intent to do something to make something new happen. So there's no cause and effect in a case study. And in naturalistic observation, they don't even know you're there. You're not trying to make anything change. Your purpose is simply to observe. So, the experiment is the only one of these four types of research that can determine cause and effect. Okay? Now, let's go on to variables. We're talking about variables. Let's define it so you understand it a little better. What is a variable? Well, your book has a definition, and it's a fine and dandy definition, but I don't think it helps you understand what a variable is any better. My definition's better. So here we go. A variable is any characteristic among your subjects that could be different between any two given subjects. So what are some of the things that could potentially be different between subjects in your research? Well, if it's humans, it could be age, it could be gender, it could be race, it could be socioeconomic status, it could be educational level, it could be height, it could be shoe size, it could be hair color, who knows what it could be. It could be a gazillion different things that could be different between subjects. That is a variable. Now, do we worry about all of those variables? Well, of course not. We probably don't care about the hair color. We probably don't care about the height or the shoe size. We probably don't care about a whole bunch of different variables that could be different between subjects. But there are some variables that we might be of concern, that we might concern ourselves with. What if Fred pretty much believes that his psychotherapy for depression is better for females than it is for males? Would that have an influence on the outcomes of the study if he didn't take gender into account? Well, think about it. If he had equal males and females in the study, and the females showed a lot of change, but the males only showed a little bit, well, the males only showing a little bit, being half the subjects, would wash out the benefit that the females experienced. And so overall as a group, the group wouldn't have changed enough. So that could be a problematic variable. Anytime You look at your subjects and you control for a variable, meaning you decide to limit males and only use females in your study. If that's what you do, then you have now limited your ability to generalize your outcomes. Because if you only use females in this study, what are you going to be able to say about males later on? Absolutely nothing. There is absolutely nothing you can say. Because you didn't include males in the study, so you don't have any evidence to suggest that males would do as well as females did. So every time you control for a variable, every time you limit something about your subjects, you diminish your ability to generalize your results to a larger group of people. But sometimes we have to control for certain variables. That's just the natural course of doing the research. So a variable is something, a characteristic that can be different between any potential subjects in a study. We also have what are called extraneous variables. The word extraneous means outside of. So in other words, this means it's a variable that has not been controlled. An extraneous variable is a variable that has not been controlled. So it's outside of our control. It's still there, but it's outside of our control. The perfect example of that is gender. So if we choose to bring females and males equally into our study, then we have not controlled for gender. Therefore, gender is an extraneous variable. It's a variable that is, at this moment, outside of our control. Now, that may be just fine. The therapy may work just fine for males and females. If that's the case, great. It works fine for males and females. But if not, then that extraneous variable could really mess up our outcomes. I already mentioned this, okay? What if the males don't perform well and the females get lots better? Well, when you add them all together, it just kind of muddles the change. So when a variable is an extraneous variable, it means it could potentially mess up our research, but we don't know if it will, and we're not controlling it. That's an extraneous variable. But if an extraneous variable does mess up your research, if it does muddle the results between the genders, then it's no longer an extraneous variable. It is now called a confounding variable. So the word confound means to confuse. And basically what it does is it confuses your outcomes. It confuses your results. So sometimes extraneous variables will mess up our study. And if they do, then we have to do another study where we control for some aspect of that variable so it doesn't mess up our study. Okay, those are the three basic types of variables I want you to know. Just the definition of a variable, definition of an extraneous variable, and the definition of a confounding variable. Now, we're going to dive into methodology. And the methodology is how we set up our study. Now again, we are not going to be talking anymore about a survey, a case study, or naturalistic observation. We're going to be talking now about the experiment. So the experiment has a cause and effect process. And what are we going to learn about that? Well, let's see. Well, I got to get something to erase off of here. Okay, let's erase what we've got on here and we'll start talking about the experiment. Now, with every experiment, we start out with an hypothesis. You already know what an hypothesis is. good educated guess. In this case, it's going to be Fred's therapy for depression works. That's our basic hypothesis with all its extra little definitions. But now we have to set up our study. How do we get our subjects? Well, let's say we're in Clark County and we want to get 100 moderately depressed people. How do we find them? It's a good question. How are we going to find 100 moderately depressed people? Well, if you've ever seen some of the advertisements that are out for people who suffer from a certain disorder and this clinic is offering free therapy because they're doing research, we could do it that way. If we were just doing a survey, we would just take a random sample of the population. This is called random sampling. How do you do that? Well, you probably go get voter records or the census records from the county, and then you simply run a random selection process. People don't understand what random really means. The term random truly means that every subject in the population has an equal probability of being selected into the sample group that's going to be used. So put names in a hat doesn't really work, because if you have 50 names in a hat and you pull out the first one, the probability of that person to be selected is 1 in 50. But then what's the probability of the second person? 1 in 49. So a random sample really does have to be done very carefully, and that's why we let a computer do it for us, because the computer can add people back in after they've selected them out and then select again and all that. But the best way we're going to be able to find people for our study, 100 moderately depressed people for Fred's therapy for depression study, we're going to have to go to clinics, to hospitals, to doctors' offices, and give them a prospectus and say, look, this is what we're doing. This is how we're going to provide the psychotherapy. It's for research and it's for free. And so they would, the different facilities would offer these things to the people who come into their office. Now, that being the case, is that group of people that have been offered psychotherapy by going to their doctor's offices, are they a representative sample of the population of moderately depressed people in Clark County? Well, they are not. And if you really look at it, there's probably about, 280, 300,000 people in Clark County. So about 2% of people are clinically depressed at any given point in time. So what's 2% of 300,000? Well, that would be about 6,000 people. How are we ever going to get those 6,000 people together to make a random sample of that 6,000 people? Well, we're not. And so do people who go to see the doctor or go to the clinic for psychotherapy, are they representative of the entire group of people who are depressed? Well, the answer to that is no, because most people who are depressed, of those people who are clinically depressed, diagnosable, that 2% of the population, only about 15% of them ever seek out any kind of treatment. Well, that means that there must be something different between people who seek out treatment versus people who don't. And we know what a lot of those reasons are. That's not something for our discussion right now. But that means that group of people that we find, that 100 people, are really not going to be very representative of the entire group of depressed people. But that's the best we can get. So we're going to get those 100 people, and then what are we going to do with them? Well, we're going to take our 100 people, our 100 moderately depressed people, and we're going to divide them up into two groups. Now, the study we're going to put together right now is an exceptionally simple study. We're making it as simplistic as we can possibly make it. We're going to divide those groups, that group, into two groups of 50 people each. But we're going to divide them with random assignment. Random assignment means we let the computer divide that 100 people into two different groups. So random assignment. So now we have two groups of 50 people each. What do we call these two groups? Well, one group, let's use another color here. One group is going to be called the experimental group. And I'll define what that means in a little bit. The other group is going to be called the control group. Experimental group and control group. And that's one of those four terms that I told you needed to know when it comes to methodology and design. So, there we have it. We got 50 people in each group. Now, what are we going to do with them? Well, in this Fred's Therapy for Depression study, we're going to give some of the people treatment. And some of the people, we're not going to give them treatment, at least for a couple weeks. Because in our prospectus, we said 2 weeks may pass before we're able to fit you in to get you some therapy. Those people who wait for 2 weeks, those people are in the control group. Those people who get therapy immediately, those people are in the experimental group. And then over a 2-week period, we're going to see what kind of change occurs from this group compared to this group. Because this group's not getting anything for 2 weeks. This group's getting 4 sessions of psychotherapy in those 2 weeks. And then we're going to see how they turn out differently. Okay, so now we're going to do a little bit of extra work here. First of all, we have to make sure that all of these people are depressed. So we're going to give them the Beck Depression Inventory. It's a 21-item test that actually is used to measure whether or not people are depressed. And let's say that our experimental group ends up with a score of 23.2, and our control group ends up with a score of 23.1. Now, are they both equal average scores in the Beck Depression Inventory? Well, no, they're not. But yes, they are. Statistically, they are, because no test is perfect. And if you've taken any kind of statistics, you understand the concept of error. And so there's a little bit of error. And that little bit of error simply says these groups are in the exact same range of depression. So we're happy about that. Because if we're going to compare them later on, then we darn well better have them be the same when they start, or that would really mess up the outcomes. Then we offer the independent variable. In this case, this is a new variable, right? What is the independent variable? Well, your book will tell you that the independent variable is the variable that you use that you manipulate among your subjects. Well, that doesn't really explain much. The independent variable is very simple. The independent variable is the cause. Remember we talked about cause and effect relationship? The independent variable is the cause. It's trying to cause change. In this case, what is that independent variable? Well, that independent variable is Fred's therapy. So Fred's TX, Fred's Therapy for Depression. It is given to the experimental group, but it is not given to the control group. And it really is that simple. It's given to the experimental group, but not given to the control group. Therefore, the independent variable is always the treatment. It's always the agent of change. It's always the thing that we try to use to make something be different. And in this case, we're giving it to one group, but not giving it to the other group. So the independent variable is always the treatment. If we were coming up with the greatest new migraine treatment, and we thought we had the new pill, well, we'd have one group that we gave the real pill to and one group we gave a fake pill to, a placebo. And then we'd measure and see if the group that got the real pill got more better than the group that got the sugar pill. Well, what would then the independent variable of that study be? Well, it would be the pill. And the pill was manipulated by the experimenter, wasn't it? It was either a real pill or it was a fake pill. In this case, we're manipulating the treatment by giving the treatment to one group and not giving the treatment to the other group. That's how it works. Okay? Then, what are we going to do? After we have given and not given, what are we going to do now with our subjects? Well, you are correct. We're going to measure them again. So the first administration of the Beck Depression Inventory was the BDI-1. This administration is the BDI-2. That means it's the second time you administered it. And now, after we administer it after 2 weeks, our experimental group now has a score of 13.1. And let's say our control group has a score of 21.9. So what would the difference be? 1.2 change, because people usually do change with time, versus 10.1 points of change. Well, actually, if they scored at a 13, then the whole group, as on an average, would be out of the range of depression, by the way. They would be in the low, mild, high, no depression level. Well, did they change enough? Did the two groups change enough? Let me take care of that glare from the window. Hopefully that's a little easier to see. Did they change enough? I don't know if they changed enough. Statistics will tell us whether or not they changed enough. But what do we call this second administration of the Beck Depression Inventory? Well, what caused this change to occur? The independent variable. Therefore, the Beck Depression Inventory is also the dependent variable, or at least the scores that we got from the Beck Depression Inventory is the dependent variable. So the dependent variable is the effect. The cause is the independent variable, the treatment. So you have the treatment and you have the outcome measure by the Beck Depression Inventory. Treatment, effect, cause, effect, independent variable, dependent variable. Now, I hope you understand that. I hope you understand these basic concepts, because you really, really, really do need to understand this to be able to understand the rest of the chapter. There are a lot of different ways that we can describe the dependent variable. Let's say we were doing the migraine medication study. And in the migraine medication study, we were giving the real pill to one group and the fake pill to another group. What would be our dependent variable? Well, there could be a lot of measures that we could use to get some results from. Those results would be our dependent variable. So perhaps one would be a rating scale where the individual would rate their migraine from the beginning of when it started to after taking the medication. That could be a very simple outcome measure. In migraine studies, they often use a measurement device that actually measures the amount of muscle tension on this band that goes around the side of the head right here, to measure how much tension there is. Therefore, that is often correlates highly with how much pain is being experienced. They could do an MRI to see if some of the larger blood vessels were constricted or not. Before medication versus after medication, or before placebo and after placebo. So those measurements, all of those different measurements, are the dependent variable. And that's what you need to remember about a dependent variable. It's what you're doing to measure the effect of the independent variable, or in this case, Fred's treatment for depression. Now, these numbers that I've created here in this study, if we got those numbers, we'd be so happy. The control group only moved about 1 point, and the experimental group moved about 10. Oh my gosh, we would be the happiest people on the face of the earth. We'd write home about that one, because those would be results that were really good to receive. Now, there are many, many other aspects to research, but we're going to keep this as simple as we can possibly keep it, because I like the KISS method, the keep it simple stupid method, because I'm stupid, so I got to keep it simple. So we start out with 100 people. That's our group of subjects. We randomly assign people to experimental and control group. How do we know the experimental group is the experimental group? Because they get the independent variable or the treatment. How do we know the control group is the control group? Because they don't get the treatment or the independent variable. And then we measure to see if there's a difference between the two groups. They started out the same, they ended up very different. Big change in the experimental group, minor change in the control group. This is how we do research. Now, this is a simple design. It's simple methodology, but it's a pretty good study. Now, keep this study in mind, because we're going to use it again. And I'm going to bring back these numbers for the second lecture. We'll bring that back again, and we'll figure out how to help you understand some of the other concepts in the second half of the lecture that starts with data collection, which is what we would start doing right now if this was what we were doing in a study. So remember, this is psychological research, and the reason we do psychological research is because that's what separates psychology from the trunk of philosophy. We become a branch of science, just like all the other sciences, by applying the scientific method. My brother, he has 2 master's degrees in engineering and chemistry, and he has worked for years for big chemical companies. And he used to always make fun of me and say that psychology was a scientific art because of its application of the scientific method. And I explained to him that we use the exact same scientific method he uses in his sciences. So, yeah, for whatever it's worth. It's pretty darn good science, and we work hard at trying to comprehend the science well. So, this is the lecture for today. Thanks for listening. Come back later. Listen to the other lecture. Hopefully it helps you to understand this chapter better. The quiz for this chapter is already available to you, and the assignment, the writing assignment, and the discussion posts and responses are already on your Canvas also. So you can take a look at them. I would wait to hear the second lecture that I'm going to add on later this evening, and then we will move on from there. So thank you very much. I hope you're doing okay. Please don't put off doing your assignments. Please don't do off completing your quizzes. Make sure you get these things done. I think I've figured out a new way to get the lectures going a little bit better, and hopefully it'll be more available to you, and it'll come to you a little more smoothly. Thanks a lot. We'll figure all this out together, and we'll talk to you soon. It's going to be a couple days before I start putting up your grades as to how you're going along the way. The reason being that I extended the assignment and quiz dates for chapters 1 and 11 just because of the confusion up front, and I don't want anybody to feel like it hasn't been fair to them. So do your best, and we'll see you in the next lecture. Bye-bye now.